Hi friends, today we are discussing the torque equation of the DC motor. What is torque? The torque is nothing but the turning or twisting moment about an axis. It is it is also measured as a product of force and the radius at which these forces act. To understand it in detail, we will consider a pulley which is connected with the shaft of a motor whose radius is of r meters and a force of F newtons is acting at this pulley rim like this. Now when this F newtons force is acted along with the pulley rim, the pulley starts to rotate in a clockwise direction at a speed of n rps, that is revolutions per second. So this is the total assumptions we are doing for calculating the torque equation. Now as per the definition, the torque is nothing but the product of force and the radius, as well as we know that the unit of the force is Newton and unit of the radius is meter. That's why the unit of torque is nothing but the Newton meter. Now the work done by the force in one revolution, we know that it is force into distance. So here force is of F Newton and the distance is nothing but the circumference of the pulley rim. That's why it is becomes F into 2 pi r joules. So this is the work done in one revolution. Now if we consider the work done per second, then it is defined as the power. That's why the power developed equals to F into 2 pi r into n. N are nothing but the number of revolutions in 1 second and its unit is joules per second or watt. So we will rearrange that equation in the form of F into r into 2 pi n. As F into r we already studied, it is nothing but the torque. That's why the 2 pi into n is nothing but the angular velocity omega in radian per second, whereas F into r is nothing but the torque in Newton meter. So the power developed is given by the angular velocity omega and the torque. So P equals to T omega in watts. Now if the speed is rpm, that is revolutions per minute, so first of all we have to calculate the omega by converting the speed in rpm into speed in rps by dividing it by 60. So we'll get the value of omega as 2 pi n upon 60 radian per second. By putting this value in the equation of power developed, P equals to 2 pi n upon 60 into T. Then we will collect the constants as 2 pi by 60 into the variables pi in t into n. So the P becomes nt upon 9.549, as the reciprocal of 2 pi upon 60 equals to 9.549. As we have to calculate the value of torque, that's why I'm taking the reciprocal of it, and finally we'll get the value of armature torque TA equals to 9.549 into power developed P upon n, that is the speed in rpm. Now next is the shaft torque. Armature torque is nothing but the torque which is actually generated inside the armature of the motor, whereas the torque which is available at the shaft of the motor is defined as a shaft torque. That's why instead of considering the power developed, for this we will consider the output power, and P out is given by the TSH is nothing but the shaft torque into 2 pi n, that is the omega, if n is in rps. So the TSH by rearranging the equation will get as output power in watts upon 2 pi n Newton meter if n is in rps, and if n is in rpm then we'll get TSH equals to output in watts upon 2 pi n upon 60 Newton meters. Then by calculating the constant, again we will get TSH equals to 60 upon output in watts, 60 into output in watts upon 2 pi n. By calculating the constant, again we will reach at the same conclusion that TSH equals to 9.549 into output power upon n in rpm in Newton meters.